In the last video, I showed how to plan and think through a RAG system. In this one, I'm going to show the code for how all of that works. I programmed everything step by step, and I'll show you everything working right here. If you watched the last video, you already know that a RAG system has 4 fundamental elements to function: data ingestion, vector database, retrieval and orchestration, and the artificial intelligence or LLM models. And here's the problem between understanding the architecture and how the system works and having this system running in production. There's a huge gap, right? I've spent the last few days implementing this in practice, writing a lot of code, debugging, exploring the Azion platform, and using its full potential. And in this video, I'm going to show you exactly how I did that. And by the end, you'll understand every important line of code in this system. I'll show you each part, how it works, how I made the decisions, and how I used Azion's products. And then you'll see the system working from end to end already in production. Look, I'll make the full code for this available in a repository, but don't go straight to it, okay? Pay attention, stay until the end of the video, because understanding how I built it, every decision I made, and how I used Azion's products to build this RAG system is just as important as using the finished system. So stick around. Before diving straight into the code, I want to show you all of this working. This is the custom copilot, as I named it, that we're going to build using that architecture from the previous video. So here I can come and ask a question. What is a microservice? And then it'll go through the whole RAG process and find the answer for me. So here it is. A microservice is part of a software architecture and so on. Each service runs a unique process, communicating through a well-defined mechanism. Here's the answer it found. And here it shows the reference of the document it found and the excerpt it found, okay? So here it is. It says which document it was. And if you notice, the document is in English. So that's one of the benefits of using LLM with RAG, because I can use the already trained LLM to translate both my question and my answer. And the coolest part is that you ask the question in natural language, the LLM model interprets it, processes the embeddings of that question, searches our vector database, finds similarities, and then finds which document is related to it. And the excerpt from that document to compose the prompt will give to the LLM. So we send the question along with the context, which is like a cheat sheet for it to generate the answer from there. And here it generates the answer. All of this happens in just a few moments. You didn't even notice while I was testing it here. Let's ask another question. What does a monolith do? Oh, it didn't find it. Look, and that's a great example. When it doesn't find it, it says, I don't know, I don't want it to generate an answer. I wrote it wrong. How does a monolith work? There, now it found an answer. It's not that confident. I made a little algorithm to calculate the confidence index. There are 3 indices, low, medium, and high. And here it's saying it found a snippet here and it says a monolith is an architecture where all components of an application are tightly integrated into a single unit. And this answer is actually correct. It has low confidence, but it's right. And here's the snippet it found where it compares monoliths, monolithic applications, and microservices, okay? So all of this happens in a few moments, very fast. It does the whole search there in our document base. Let's say it increases the context of the LLM call along with the question and brings us the answer. Important, this isn't a prototype, it's code ready to run in production. I'm already running it in production. I have a link running within Azion's highly distributed network. This is a production environment, okay? Now let's see how it works, how this project of ours is organized. I basically broke it down into all those parts I showed in the previous video between data ingestion, retrieval orchestration, and then there's the model part as well. And then the database part is over at Azion, so I didn't need to build it here. The database is already there. And then I made that extra 5th part, which is the UI, which is this web part here, which is a React app, which is what I just showed you. I won't even go into that detail, okay? So let's start with the data ingestion part. Here, look, I made a small project using TypeScript, okay? And I have some Markdown documents here, see? These Markdown documents are what I use for it to index and put everything there in my database. And then the one that does all this indexing work is precisely this file here. So I have some functions here. I'm just going to show the important parts. It starts doing it and then it breaks it into chunks. So chunks, as I explained in the previous video, are snippets of your document for it to index. And I have a 10% overlap. So I created a chunk here of 1000 characters and a 10% overlap, so that'll be 100 characters, right? And then this makes the overlap carry the context from the previous chunk to the next chunk, you see? And then I have this logic here, breaking the chunks. But the coolest part is this embedding part here. Here I have an AI lib. Here I just abstracted the model calls. I'm using Azion's AI Inference models. But here I created a library to abstract it and not have to keep calling it the same way, building prompts and all that. So here in the embedding, we can even go straight to this function. I receive the text, the dimension, the size of it that I want to process, and so on. And here I have some control variables here. But basically, I come in, set up the call for this model. So here's the model I'm using to do embedding. And this is the format I'm calling it in. And here I call the AI model, which is basically this right here. So I set up the call there. And here I call Azion AI.run to call the embedding model. So from there, it will process this text, and it will return the embed to me, which is a list, an array, a huge vector of numbers. I have thousands of them here. And then after that, it called here. Then I'm going to insert it into the database. And here, inserting into the database, I did let's say two executions. One is I insert directly into the database itself, and the other I create here an SQL file with all these insertions. So we can see, analyze what it's inserting into the database. So here I created a table. Here's my table that I created. Simple, basically simple. I could add more things here, but I have the ID, the file name, the content I processed in the embedding, which is the vector itself. And the date I inserted it there just so I have it as a reference, okay? So it's very simple. But here I could add metadata, I could add some other details, categories, and things like that, you know? I did it in a very simple way as a way to demonstrate it in an easier way for you. And here are the inserts of these vectors into my table. So here's the table, here's the name of the file I processed, the snippet, and towards the end there'll be the vector. Look at the vector here, see? It's a huge list of numbers, see? The list is huge. Look there, I'll scroll here and there'll be numbers here, see? So I wanted to put this here just to demonstrate to you in practice what a vector is, you know? What an embedding is. And who generates this? It's an artificial intelligence model that's running there in Azion's AI Inference. We've already seen part 1, which is data ingestion. We've already seen part 2, which is Azion's vector database. Now let's go to part 3, which is retrieval orchestration. It might be the most complex part of this whole RAG system here. Now that we've already processed our documents, vectorized dozens of snippets from each document, now what are we going to do? Receive a question and process that question to find the relevant documents there. So here, let's close this. I have the retrieval orchestration here. I created a serverless function here, okay? That uses the HONO framework. Basically, it's an HTTP system. So I have two endpoints here, search and ask, but I'm basically just using ask, which is for asking it questions. And it calls this question function here, okay? So here, look, I've commented everything nicely so you can follow along properly, okay? So first, the only thing it receives is the question. It's a string with the question. From there, we're going to process that question, which is this search. Where's the search? It's here. What's the search going to do? First, we're going to do the embedding. Just like we did with those chunks processing the document, we'll do the embedding for this question. In other words, we want to find the vector similar to the question with the similar answer we have in the database. So here, look, I do the same embedding process, find the array I want, here's the array, the vector I want, and then from this vector, I'll query my database using a Cosine mathematical formula. I'm going to calculate the distance between my question and the answers I have stored here in my database. And I called this calculation similarity, meaning I want to see which one is closest between the question and the answer based on this embedding. And this number can range from 0 to 1. 0 means no similarity and 1 means total similarity. It's exactly what I'm looking for, you see? And then here, doing this calculation, I perform this, let's say, query here and sort it. I limit it to the top 5 most similar answers, okay? And then here I'll do some calculations and all that. You'll see exactly later. But the important part is this re-rank, meaning I call another AI model again to rank which answer is closest to what I'm looking for. And then going back to the question, I now perform another similarity filter, meaning I only want things with more than 20% similarity, so 0.2 and up, to be brought in as a reference for it to find this answer. And then here I build the actual prompt for my question. So here, look, I put in its instruction. First I say it's a help assistant. Its job is to find answers. And then I give a whole instruction, but the other important part is here. You must always respond in Brazilian Portuguese. And here's the other part. If you don't know the answer, if you didn't find the answer, simply say, you don't know. I don't want it to make up an answer. And then here in the user call part, right? Here I'm just defining the system prompt. Here I'm defining the user prompt. I provide the context, which is all the documents I found, along with the question, and it will find the answer to that question within this context. And then again, here I call the artificial intelligence model, this time using the chat. And for the chat, I'm using another model, which is Mistral. And then this model will process the question along with the context and generate this response. There's room here for you to adjust everything the way you want and however is best for your use case. So you can change the model, you can improve that prompt. You can adjust all the similarity rules, the similarity calculation. What I'm talking about is this part right here. Whether you want more than 20% or you want it higher, 75%, and so on. I set it to 20% because in some tests, it wasn't returning the results, the context I wanted, because I have little data here. I have very few documents. But most of the documents are all about Azion documentation, talking about monoliths, about microservices, talking about MCP. There are also questions here. There's documentation on RAG. So we can ask it questions about all of that. And this here is a Markdown document. Markdown documents are better for artificial intelligence to process. So if you have, I don't know, PDFs, PPTs, slides in Google Slides, the ideal thing is to pre-process those files and transform all of that into Markdown before processing it to generate the vector, the embedding that you need, okay? These LLM models are language models. So the closer to plain text you have, the better, okay? So then all this RAG part here is the part that's right here, look. Remember this model I showed in the previous video? So first I ask the question, then I process the embedding of that question, then I search my database for possible answers for that vector, rank it, and then I generate the prompt. All right? So it's all here. I haven't implemented any guardrails or security, but if you're going to, it's all at this stage here in orchestration as well. So when I receive my HTTP request here, I could put authentication, authorization, validate if the question is related to the purpose of this RAG model. Let's say you created an assistant for your customer support. If they ask what the score of the game was last weekend, it shouldn't answer, right? It should answer support questions about your application, your company. So it's at this point where you can do all these treatments even before querying the database, calculating similarity, calling LLM models. Now what I'm going to do for you here, I'm going to run a data ingestion here. So I'm going to run this data ingestion file here so you can see how it works, okay? What's the instruction here? Start PNPM start. PNPM start. So now what's it going to do? As soon as I hit enter, it's going to clear my ingestion table because I programmed it to always reset the ingestion table and start processing everything again, calling the LLM model. I've set up a logging system here just to show how it breaks things into chunks. So here's the document, this one. So here's the document, this one. Designing microservices application. It's breaking it into several chunks. Look, the first, second, third, and fourth are done, and so on. It processes it chunk by chunk. So it takes that part of the document, calls the embedding model, and comes back to insert it into the database. In the meantime, we can see our insert file. It's inserting here, adding lines. Which are the lines it's already putting into my database? Look, it's switched documents now. So the first document made 10 chunks, and now it's moving to the second one. And so it goes. I'll let it run. Everything's embedded and in the database. Now we'll deploy the function for retrieval orchestration. So I'm here in my retrieval orchestration folder. Now I just type Azion deploy. Then I use debug local debug because I want to see the step-by-step deploy and local, because I wanted to build this function right here on my machine, and just send the ready-made bundle to the Azion network, okay? And while it's deploying, let me explain. The cool thing about using Azion for this is that it's a highly distributed network. We're in over 150 locations worldwide. So depending on who's using your RAG system, it'll use the edge location closest to them. That means better performance and less latency. And everything will be there together. The function, the database, the AI inference model, all of this reduces the complexity of managing and orchestrating all the systems, but it also cuts down processing time and data transfer time across the internet. And look, it's done. Our function is ready right here. Now it's available on Azion's highly distributed network. Let's go here. This is our function running in the actual production environment, okay? The URL is different here because we're accessing the UI, not the function itself. But we could access the function by making direct HTTP calls from there, right? And so here we can ask, what is RAG? Because if you go back, one of the documents we ingested is about RAG. And now we can ask any question that's inside these documents. So I can ask here, how is it designing microservices? How do you go about designing a microservice in practice? And look, it already found it, which is one of the documents in there. See, to design a microservice, it's crucial to understand its key features, a well-designed microservice, and so on. And then it explains exactly what it is and gives the reference it found here. See? So man, that's it. A RAG system working right here in front of you. The repository is shared with you so you can tinker with it, just clone it, play around with it however you want, add your own documents, and start fine-tuning it. Whether it's when calculating similarity, or when processing the question embeddings, or when inserting it into the database, you can insert it by loading, for example, metadata, categorizing, and all that, you know? We've implemented a complete RAG system here, 100% on the Azion platform. From ingestion, storing documents in the database, to the whole orchestration of receiving the question, processing, and everything else 100% on Azion. This code is available on my GitHub. I've left the link in the description, and you can use this system in your production environment. The 4 pillars of a RAG system were implemented here, and I've shown you step by step. Data ingestion, vector database, retrieval and orchestration, and AI inference. If you want to go further, now you just need to implement guardrails, user authentication and authorization, handle the questions before even querying the database, and so on. But the base code is right here ready for you. And if you implement something using this example I gave you, tag me. I want to know. Tag both Azion and me on your social media. I love seeing your projects running. I've linked another video here for you to keep watching and learn a bit more about Azion. And in the description, there's a link for you to create your Azion account. And as soon as you create it, you get $300 in credit. So you can do everything I showed you and much more without spending a dime, okay? Look, a great gift. Now that the end of the year is coming, a great gift for you, huh? Thanks. Click on the related video because this video is over now. See you.